Today we're talking about the probability of compound events. Before we do that, just to review from yesterday, in order to find the probability of a single event, we said we do the number of favorable outcomes divided by the number of possible outcomes. That's just like the worksheet we finished reviewing right now. Yes or no? Okay, so today in compound events we will have independent and dependent events. So let's start by talking about the independent events. Independent events are events that do not influence one another. For example, rolling two separate dice would be independent events. Rolling one dice and what I get in that dice does not affect what I roll on the second dice. They're independent events. Another example of independent events would be from a stack of cards, from a deck of cards. What is the probability of choosing a king of hearts and rolling a dice? These are each independent events. What happens in one does not affect what happens on the other one. Another example of an independent event would be having a baggie with beets in it and choosing the probability of choosing a yellow beet, replacing it, that means putting it back in the bag, and then choosing again and trying to find the probability of them choosing a purple beet. So we had a bag of different things or different colored beets in there. We choose one, replace it, and then choose again. That means these are independent events. If A and B are independent events, you find the probability of two independent events by multiplying the probability of each event. Suppose you are rolling two number cubes. What is the probability you will roll a 5 on the first cube and a 3 on the second cube? So we said that the probability of compound events, a probability of A, a probability of B, was equal to the probability of A times the probability of B. So the probability of A here is the first cube, which would be a 5. The probability of B here would be the second cube, which would be a 3. So what is the probability of rolling a 5 on a number cube? How many 5s on one number cube? There is one 5, right? So that means 1 out of 6. How many 3s on a number cube? Only one 3. That means 1 out of 6. This is what we're trying to roll. If we multiply these, 1 times 1 is 1, and 6 times 6 is 36. That means the probability of rolling a 5 on one number cube and rolling a 3 on the other number cube is 1 out of 36. Should we try it? Let's try it. So what if I roll these things? What did I roll? 2. I rolled a 2 and a 5. But is that what we wanted? Did we get the 3 and the 5? What happens if I roll them separately? Does it change anything? If I roll one cube and I roll a 3, then I roll another one and I roll the 2. Are these independent events? Yes, these are independent events. This is the probability of finding the compound probability of finding the probability of two events that are independent. What happens on one cube does not affect what happens on the other one. And I can keep rolling. How likely am I to be able to roll the 5 and the 3? Am I very likely or not very likely? Not very likely. Dependent events are events that influence each other. An example of dependent events would be having this baggie with yellow, green, and purple beads, taking one bead, not replacing it, and having to choose again. So the act of not replacing the bead is what makes choosing the next bead dependent on what happened with the first bead. The probability of two dependent events, if events A and B are dependent, is the probability of A then B is equal to the probability of A times the probability of B. So let's try an example. What is the probability of choosing a vowel, not replacing the letter, and then choosing a consonant? So in other words, we're already wanting the probability of a vowel and then a consonant. How many vowels are in the word probability? 4 vowels. How many consonants in the word probability? 7. How many total letters? Total letters are 11. So we turn these around. We need the probability of a vowel and then a consonant. Yes or no? How many total letters here? 11. What is the probability that I choose a vowel? 4 out of 11. There are 4 vowels out of 11. So I'm going to choose one and I am not replacing it. That means that the next event is dependent on whatever I chose the first time, right? I already have one in my hand. How many letters are left in here? 10. So now the probability of a consonant is how many consonants in the letter? In the word? 7 out of 10. See how our denominator changed. Our possibilities in our set are now 1 less. Why is it 1 less? Because I took one and did not replace it. 4 times 7 is 28, and 11 times 10 is 110. Can we simplify this? It's divisible by 2. So 14 over 55.